Welcome to Math with Professor V. Here's your latest integral of the day. We have an indefinite integral of 1 over 2 rad x plus 3 plus x dx. So pause the video if you want to try it on your own. I'll give you a hint. You need to do u sub first. All right, so let's jump right in. In this case, what I'm going to do is let u be this entire radical expression in the denominator. So let's let u equal the square root of x plus 3. And then I need to figure out what du is, but what works out really nicely is not taking the derivative just yet. Square both sides first. Oh my goodness, it's going to make it so much nicer. So u squared would equal x plus 3. And then now I can take the derivative so much more easily. I don't have to contend with the radical. So derivative of u squared would be 2u du, and then derivative of x is just 1 dx. So that's perfect. This 2u du is going to replace dx in the numerator. And then I already see here, okay, u is rad x plus 3, so that's going to go right there. I just have this pesky little x still bothering me, and I need to rewrite that in terms of u. So how to do that? You're just going to come right here. Remember when we figured out u squared was x plus 3? That means x is equal to u squared minus 3. So that's what I'm going to replace that little x with in the denominator. So now we're ready. And you don't want to do it half and half in bits and pieces. If your integral is in terms of x, it should be all in terms of x, and then you switch to being all in terms of u in the next step. Okay, keep things well defined, please. So in the numerator, instead of dx, I have 2u du. In the denominator, 2u, that's 2 instead of rad x plus 3u, plus, and then remember that x is going to get replaced with u squared minus 3. u squared minus 3. Okay, take a look at what's going on. Maybe you'd feel better if we wrote the denominator in descending powers. So 2u du over u squared plus 2u minus 3. And I'm looking, this is a rational function, right? Denominator is already higher degree than the numerator, so we can just go ahead and find the partial fraction decomposition. I'm already checking, yep, this denominator is going to factor, so it looks like that's a beautiful way to go. How fabulous. Okay, so partial fraction time. We have 2u over, the denominator factors into u plus 3 times u minus 1. Both of the factors are linear, and they're not repeated. So I'm just going to have constants in the top. A over u plus 3 plus b over u minus 1. Good? Okay, now to solve for the constants a and b, I'm going to multiply through by the LCD, u plus 3, u minus 1. And then on the left, we're just going to have 2u equals, distribute, distribute. This is a times u minus 1 plus b times u plus 3. Very good. From here, a couple ways you can solve. You can distribute everything out on the right-hand side, or you can substitute in values for u that would make each of these quantities 0, one at a time. So let's try that way. It's kind of fun. So let's let u equal 1. Then on the left-hand side, I'm going to have 2 equals a times 0 plus b times 4. So 2 equals 4b, that means b is a half. And then again, let's repeat. This time I'm going to let u equal negative 3. I'm picking values that are going to make each of these little factors 0, you see? Okay, so if u is negative 3 on the left, I'm going to have negative 6 equals a times negative 4, plus b times 0. So negative 6 equals negative 4a. That means a is equal to 3/2. All right, perfect. So now I'm going to rewrite my integrand, this time using the partial fraction decomposition, and we can finish off the problem. So now we're going to have a was 3/2 over u plus 3 plus b was 1/2 over u minus 1, put parentheses, please, du. Are we good? Okay. Each of these, taking the antiderivative is no big deal, just ln, absolute value of the denominator for each of them. And those constants just come along for the ride. So just keep the 3/2 ln absolute value u plus 3 plus 1/2 ln absolute value u minus 1, and then immediately you need to put plus c. As soon as you evaluate your antiderivative, as long as it's indefinite, meaning there's no limits of integration, you have to put plus c right away, first step. And then remember, we need to go back, replace u with rad x plus 3. So this is 3/2 natural log absolute value rad x plus 3 plus 3 plus 1/2 natural log absolute value radical x plus 3 minus 1 plus c. Now, upon further investigation, if you look here, if I take square root of x plus 3, that's never negative. And then if I add 3 to it, not a chance it's going to be negative. So I can go ahead, drop these absolute values and replace them with parentheses, should I so choose. So 3/2 ln, you can write rad x plus 3 plus 3. That's not the case over here because I'm subtracting 1. So if this quantity for some reason is not strictly greater than 1, we're going to have a problem, and we need to keep those absolute value bars because remember, domain of natural log, this argument has to be positive. So the second natural log, you have to keep the absolute value bars. We're not guaranteed that what's inside is always positive, okay? So the first one you can switch. If this had been a +1 instead of a -1, then yeah, we could have put parentheses. I think they wanted to make sure they kept us on our toes, don't you? Who's they? All right, so that concludes the integral of the day. I thought this one was lovely. I hope you enjoyed it as much as I did. So anyways, give the video a thumbs up, comment down below. Let me know where you're viewing from. I have so many subscribers and viewers from all over the world. It's really exciting. I teach in the United States of America at a community college, but I'm happy and excited that I get to help students everywhere learn calculus more easily. Subscribe if you haven't already, and if you need full-length video lectures on integration techniques or reviewing Calculus 1 concepts, Calculus 3 even, I have it all organized into playlists. I even have linear algebra and differential equations videos for members. So just click that join button and you can access all of that. And you can also follow me on Instagram, TikTok, and Twitter, Math with Professor V. Give me a follow there. I'd love to see you all. And I'll be back sooner than later. Bye. Love you all.